on. We're out in the hallway taking notes. The first problem that we're going to do is a squared plus 18a plus 80. This is a trinomial. Now, is this one of the simple ones, or is this one of the ones that needs like the slide divide or like the box method? Simple one, or is this one of the more complicated ones? Look at your notes. Look at the first part. Now, is there a GCF? There is not a GCF. So this is one of the more simple ones. This is not a slide divide problem. This is not, or like a box method. So this one, since it's a more simple one, you just look and you're saying, okay, what multiplies to 80 but adds to 18? That's what we're looking for. What are two numbers that multiply to 80 but add to 18? So you're going to have two sets of parentheses. Okay? And every single one of you, this is on your bingo card. There's not a single problem that will not be on your bingo card. Okay? So once you have it written down, find it on your bingo card, and then we're going to move on to the next problem.
Do we mark on the bingo?
Yep, you can write on the bingo card. So the notebook paper is how you're getting credit for participating. The bingo card is how you try to win the extra credit. You could, it should be an A, and then it's a positive number, A plus. You can shade it in, you can put a smiley face, you can do whatever you want. When we're done with this, I do not want the bingo cards back. We're going to throw them away.
Well, on the sides, we write the 8 and 10, right?
All right, the next one we are factoring is x squared minus 9x. This is not a trinomial. This is a binomial. It only has two terms. And when we factor binomials, there's only, from our notes, there's only two types of factoring that work with binomials. The first one is GCF, because that always works. That works with any type of factoring, and to look for a GCF. The second type is to look to see if the problem is a difference of squares problem. So this could be GCF, or it could be difference of squares. So if you look here, GCF or difference of squares. GCF or difference of squares. Anyone know which type this is? This is a GCF problem. This is a GCF problem. So that means you're going to take something out, and then it's only going to have one set of parentheses.
Why did you take an X out?
It is not a difference of squares because of the x right here. If it had said x squared minus 9, if that was the problem, that would be difference of squares. But because it says x squared minus 9x, it's a GCF problem. So we're going to look between the two terms, we're going to see what's in common, and we're going to take it out and put it in the front. And then we're going to write our leftovers. Okay? And once you get it, it is on your bingo sheet. For every single person, it's on their bingo sheet. All right, are we finding it? Yes? Okay. All right, here's the next one. V squared minus 36. So again, this is a binomial. It's two terms. It's either a GCF problem or it's a difference of squares problem. This one is a difference of squares. How can we tell?
Because the one number doesn't have an X.
Yeah, this number doesn't have an X on it This is a perfect square. V squared is a perfect square. 36 is a perfect square. Okay, so this one's going to have two sets of parentheses, one with a plus, one with a minus. So we're not going to solve it. We're just going to figure out what the numbers are. And if you look at your notes, do you see the example in your notes?
We just do that exact thing.
You use the same idea. So the one in your notes had a GCF that I took out first, but you can look at it after. So after that, I said x squared minus 16, and I took the square root of 16, and so in the parentheses, I put a 4 and a 4. So here, you're going to look at the perfect square 36, and what are you going to put in the parentheses? And then from the v squared, what are you going to put here and here? All right. Everyone finding it on their bingo sheet? Yes? Okay. All right, here's the next one. All right, 5x squared minus 17x minus 12. So this one's a trinomial, just like the first one. We're definitely going to have two sets of parentheses. This one has a 5 in the front. Is the 5 in the front a GCF? No, it's not a GCF. Okay, so this is one of the ones in the video I called it a slide divide. And then I've learned since I've been at this school that you guys have not learned the slide divide method. But as I've been working with students at this school, a lot of students tend to not like the box method that they've learned. They tend to like the slide divide method. That's what I figured out as a teacher here, okay? And then if you've done Elevate, like Sarah has, you guys are learning the grouping method. A lot of students don't really like that either. So the slide divide method starts off, and every method starts off with this. We take the 5, we multiply it by the negative 12, and 5 times negative 12 is what? Negative 60. So we're looking for two numbers that multiply to negative 60 and add to negative 17. Do not say it if you know what they are. If multiplication is not your strong suit, then to figure out the two numbers, you can grab your graphing calculator and you can hit the y equals button. So right up here. The y equals button is right up here. So right there. So if multiplication is not your strong suit, you can hit the y equals button and you can type negative 60 divided by x. So remember on your calculators, there's a difference between the negative button and the minus button. So if we're typing negative 60, we're using this button down here. So negative 60 divided by, and then the x is right there. Negative 60 divided by x is what I'm typing in. And I'm not actually going to graph it because I don't care what the graph looks like. I'm actually going to use the table. I'm going to use the table to figure out what are the numbers that multiply to negative 60. So now I'm going to hit second graph, and this gives me a list of all the numbers that multiply to negative 60. And my next goal is to figure out which of those numbers that multiplies to negative 60 also adds to negative 17. So I can just start to run myself through the list. 1 and negative 60 multiplies to negative 60, but it adds to negative 59. So that's too big of a negative number. 2 and negative 30 multiplies to negative 60, but it adds to negative 28. That's too big of a negative number. 3 and negative 20 multiplies to negative 60, and it adds to what? Negative 17, which is exactly what we wanted. So I'm going to use 3 and negative 20. Okay? And anytime you need me to remind you of that trick, I will remind you of how to do that. All right? Okay, so the slide divide method says I take these two numbers, I put them in parentheses, x plus 3, x minus 20, and then I take the number that I slid over, the 5, and I divide by that number. If I slid the 5, I divide by the 5. Then I take these fractions and I look to see if they can be simplified. So 3 over 5, that cannot be simplified. That's just 3/5. What about 20 over 5? Yeah, that's 4. So this parenthesis is going to be x minus 4. That one is done. If you have a parenthesis where the fraction has been simplified and it's still a fraction, or where the fraction cannot be simplified at all, then you're going to take the bottom of the fraction and you're going to bottoms up. You're going to move the bottom to the front of the variable. So 5x plus 3. So some people call the method slide divide. Some people call the method slide divide bottoms up. Yeah. No, it's fine. No, it's fine. All right. So look for that on your bingo sheet. Okay, we're going to try another one of those just to make sure that we can do it. So we're going to do 5n squared plus 12n minus 9. 5n squared plus 12n minus 9. So the first thing we do is we take the 5 and we do what with it? Multiply it by -9. Okay, so we're looking for two numbers that multiply to -45, because 5 times -9 is -45. So two numbers that multiply to -45 that add to 12. And if multiplication is not our strong suit, then we're going to go to our y equals screen, and we're going to look for numbers that multiply to -45 by typing in -45 divided by x. And we're going to look at the table by typing second graph. Second graph. And that gives us all of our options. And when I'm looking at my options, I automatically ignore any option that has a decimal. I only look at my options with my whole numbers. So here, 1 and -45, that adds to a negative number. If you can already see that it's adding to negatives and you want it to add to a positive number, all you need to do is just take this and then go the opposite direction on the table. -1 and +45 adds to +44, and now I can see, oh, I'm going in the right direction. Okay, so we've got -3, +15. So we take those numbers, we put them in our parentheses, n minus 3, n plus 15, and then we take the number that we slid over. It's a coincidence, it happens to be a 5. It was a 5 in the last problem, it's a 5 in this problem, but sometimes it's a different number. So we take the number we slid over and we divide by that number. So divide by 5, divide by 5. Now, if you have a fraction where you can reduce the fraction, then you should reduce it. So 3 over 5, can that reduce? No. 15 over 5, yes. What should that become? 3. So n plus 3. And then the 3 over 5 does not reduce, so what do we do with the bottom of the fraction? We move it to the front. 5n minus 3. Okay. All right, I'm going to give you one. We're going to see how we can do with this one, trying most of the steps on our own. So we're going to do 2k squared plus 7k minus 72. 2k squared plus 7k minus 72. Anyone want to share what they're getting as their final answer? Liz, what'd you get? Do I need to explain any specific part of it? Okay. Anybody getting close to a bingo? Yes? Yeah. Getting close to some extra credit. Okay. All right, number 7. Okay. 42x squared minus 36x. It's got two terms, so it could either be GCF or it could be difference of squares. GCF or it could be difference of squares. GCF problem. I see a 36, which is a perfect square, but the x ruins it, right? The 42 also ruins it. 42 is not a perfect square. So this is a GCF problem. So we're going to do it just like number 2. Mm-hmm. Anyone figure out what's in common between a 36 and a 42? 6. All right. Number 8. So there's a little hint for you guys if you have gotten stuck. Okay. Next one. N squared minus 9n plus 8. N squared minus 9n plus 8. So is this a slide divide problem? Yeah, so if you look in the front, does it have a number in the front? No. So if we look back at number 1, it looks the most like number 1, which was not a slide divide problem. So this is one of the more simple ones. We like it when this happens. If there's no number in the front, it is not slide divide. You just have to look for what multiplies to be the end number and adds to be the middle number. You find your two numbers, you put them in parentheses, you're done. It's a lot more simple. So the more complicated ones are the ones where you have a number in the front that's not a GCF, and then you got to do the slide divide method. These ones are a lot more simple. So here we're looking for what multiplies to a positive 8 but adds to a negative 9. And once we get those numbers, we just got to put them in the parentheses and we're good. All right, here's the next one. N squared plus 12n plus 32. N squared plus 12n plus 32. N squared plus 12n plus 32. Is this a slide divide problem? It is not. It's just one of the simple ones. What multiplies to 32 but adds to 12? Okay. Here's the next one. Three b squared plus 14b minus 24. Mm-hmm. All right, and then here's the next one. Is this one of the simple ones? No, this is a slide divide. How do you know it's a slide divide? Because there's a 3 in the front, and the 3 in the front, it's not a GCF. We can't pull it out and turn it into one of the simple ones. That 3 has to stay. Anybody got their bingo yet? Possibly? Maybe, we're not sure. You get extra credit on the quiz. Ooh, yeah. Yeah, it's worth it. Oh. You just have to tell me what your answers are.
I got parentheses n minus 1, parentheses n minus 8.
Okay.
I got parentheses a plus 8, and then parentheses a plus 10.
Okay.
Then I got a free space.
Okay.
Then I got x parentheses x minus 9.
Okay.
Then I got parentheses 3b minus 4,
Mm-hmm.
parentheses b plus 6.
Okay. Okay. I think we're going to have to switch over to the other type of factoring that we're learning how to do. How do you guys feel about factoring? A little bit better? Okay. So take this, put it in a pile on your desk. We're going to turn it in. We're going to make sure we get credit for it. So those of you guys who did your notes out in the hall, you need to, there were 10 problems we did. You need to do 10 factoring problems. You can go back and watch this video, okay? Because this has us going through the problems, all right? I sure do. It's right up here. Okay. So we're going to get our factoring notes back out. We're going to add to our factoring notes from last night. For these notes, you need 2 colors. They can be pens, they can be pencils, colored pencils, they can be markers, they can be highlighters, something that you can write in 2 different colors, okay? We need 2 different colors. I haven't. No, I did check those. Let me come by in a little bit and look at yours. Yep. So we did, in the video, we did 4 types of factoring. This is the 5th type of factoring. After we do these notes. Yep. Okay, this is going to be our fifth type of factoring. This should be brand new to you. Brand new. Okay, so we know that we can factor the difference of squares, but we're going to learn how to factor the sum and difference of cubes. There are formulas for it, but the formulas are kind of hard to memorize. So what I do is I teach it using two different colors because the pattern is a little bit easier to memorize than the formula. So what we're going to do is we're going to write down the formula, but then we're actually going to practice the pattern using our two different colors. Okay? So the formula is we could have the sum version. We could have a cubed plus b cubed. And if we have the sum version, then our first set of parentheses would be a plus b. This is for the formula. And the second set of parentheses would be a squared minus ab plus b squared. And then the difference version would be a cubed minus b cubed. The first set of parentheses would be a minus b. The second set of parentheses would be a squared plus ab plus b squared. And they're similar, but they're slightly different, and it tends to confuse students if they try to use the formulas, or it's hard to memorize. And so instead of using the formulas, that's why I like to help students use just a pattern instead. So the first thing that we're going to remember is how to keep track of the signs, because you can see that there's definitely a pattern with the signs here. So the first sign is the same as the original problem. So if the original problem is a sum, then this sign is going to be a plus. If the original problem is a difference, then the first sign is going to be a minus. The second sign is going to be the opposite. So same sign, then the opposite sign. And then the last sign is going to always be positive. So the acronym that we remember is SOAP. Same sign, opposite sign, always positive. SOAP. Okay. After that, we do colors. So I'm just going to go ahead and take this formula and I'm going to write it using colors. So I'm going to say a cubed plus b cubed. I'm going to use the first color for the A. And I'm going to use my second color for my B. So if I rewrite the formula, oh, hold on, let me erase the whiteboard. Sorry guys, that's been up there the whole time. Apologies. Okay, so for the first set of parentheses, if I do the colors, I'm going to have A plus B. So you can see the pattern is, for the small set of parentheses, half the parenthesis is in one color, half the parenthesis is in the other color. Okay? For the next set of parentheses, for the first term, it is A squared. So I'm going to write A times A. Then I've got plus, and for the next term, I have A multiplied by B, A times B. And then for the last term, I have plus B multiplied by B. Again, you can see the pattern is that in this longer set of parentheses, the first half of the parenthesis is one color. The second half of the parenthesis is another color. Do you guys see that? Yeah. So one color, another color, one color, another color. Okay? Here we've got the letter once, the letter twice. So, well, once, and then we've got 2, 2, 2. See the pattern? So the colors are split half and half, half and half. And then for the small set of parentheses, we've got each letter once, and then for the big set of parentheses, we've got twice, twice, twice. And that's kind of how the pattern works. So if we can remember how that pattern works, we don't have to memorize a formula. Okay? So now let's go ahead and try it with some numbers. Before we do an example problem with the numbers, we're going to write down all the perfect cubes off to the side so that we can recognize them. So 1 cubed is 1. 2 to the third power, anyone know? 2 times 2 times 2 is 8. 3 to the third, 3 times 3 times 3? 27. 4 to the third, 4 times 4 times 4? 64. 5 to the third, 5 times 5 times 5? 125. 6 to the third, 6 times 6 times 6? 200. You all have calculators. 200. 216. 7 to the third. 343. And we're going to do one more. We'll do 8 to the third. 5, what is it? 512? Okay. All right, so here's our first example problem. We're going to write 8x to the third minus 27. So the first thing we want to do is we want to find out what our A value is and what our B value is so that we can plug things into the pattern. So I need to write this as something to the third minus something to the third. So if it's 8x to the third, what must have multiplied by itself 3 times? 2, and then what else?
3.
So 2 and a 3, but what else? How do we get the x there? 2x. So it was 2x times 2x times 2x. That's how they got 2x to the third. 2x times 2x times 2x. And then over here, we had 3 times 3 times 3. That's how they got the 27. So I'm going to put my little set of parentheses and my big set of parentheses. I'm going to put my same sign, my opposite sign, my always positive sign. So same sign, opposite sign, always positive. And then I'm going to go ahead and I'm going to grab my colors. Okay? So first color goes with A, that's 2x. And I write it once in the first set of parentheses. And in the second set of parentheses, we do 2, 2, 2. But each color only gets half. Okay? So I'm going to do 2x times 2x. 2x times, but I have to stop because I'm halfway through the parenthesis. Does that make sense? Okay? Now I switch colors. And I do the other half of the parentheses. 3, I got my times, 3 times 3. So I've got 1 and 1, I've got 2, 2, 2, and I've got my colors for half of the parentheses. So I followed the pattern. And now all I have to do is fix my parentheses so that I have multiplied things, cleaned it up, and made it look like math instead of art. So 2x minus 3 is my first set of parentheses. My second set of parentheses is 2x times 2x, which is 4x squared, plus 6x plus 9. Final answer. Now, if you could factor that second set of parentheses using slide divide, you would. But that second set of parentheses almost never is factorable. In fact, if you said, Miss Rice, could you find us an example problem where you can factor that second set of parentheses, I would say, no, I cannot. I'm not going to spend the hours on Google trying to find one, because hardly any of these actually factor with that second set of parentheses. Most of them do not. Okay, so we factor this using SOAP, using our colors. We get down to the end, we stop because most likely that second part is not factorable. Okay, how do your brains feel? Horrible? Let's try it again. Let's do another pattern. Okay, so the next one we're going to try, we're going to do 125 plus 343 m to the third. My brain says, why did you write this backwards? I'm uncomfortable with that. Anybody else feel that way? Yes. Okay, I'm going to go ahead and switch the order because I don't like it written like this. And I have to do something to the third plus something to the third. So what should I have first? 7m. Okay, what should I have second? 5. Okay, so we're going to have a little set of parentheses and a big set of parentheses. And we're going to remember SOAP. So we have the same sign, the opposite sign, and always positive. And now I'm going to do my colors. So I do my first color once for the small parentheses and twice for the big parentheses. So 7m times 7m, 7m times, but I stop because it's time to switch colors. And then for my other color, I'm going to do 5 once for the small parenthesis, and then twice for the big parenthesis. Okay. So our small parentheses are 7m plus 5. Our big parentheses are 49m squared minus 35m plus 25. How was it that time? Better that time? Okay. Mm-hmm. Okay, we're going to do one more just to make sure that we're really set. So this one is going to be 2 minus 54x to the third. Is anyone uncomfortable with the way that this one's written? Yeah. Ugh, I don't like it. Okay, so it's in the wrong order. We have to switch the order. So if I do that, this term has to be written first, but that term is negative, so I have to take the negative with it. And that term is positive. Now, this must be a cube problem, but none of the numbers are cubes. Did you notice that? A 54 and a 2. I also have a negative in front. We never talked about that. So, what do you guys see that could be going on here? Starts with a G. GCF. There's a GCF in this problem. So, anytime you see a negative in the front, you're going to have to take a GCF out, at least of a negative. It is not proper when you're factoring to leave a negative in the front. So we do have to take the negative out. And then both of these are even numbers, so we're for sure going to have to divide out a 2. Okay, so we're going to take a -2 out as a GCF. Okay, so -54 divided by -2 is 27. There's our cube right there, 27. And then +2 divided by -2 is -1. There's our other cube. So what we're going to do is we're going to ignore this -2. It's going to show up in our final answer. We're going to pretend that this is the problem we're doing. We're going to ignore the -2 until the final answer. We're going to pretend that this is what we're doing. Does that make sense? Okay, so when we get down to the very end of the problem, we're going to have a little set of parentheses, we're going to have a big set of parentheses, we're going to have a GCF of -2 sitting in the front. Does that make sense? Okay, so I'm going to ignore the GCF of -2. I'm going to say, okay, let's go ahead and rewrite this as something cubed minus something cubed. And what numbers should we be putting in here? 3x and a 1, okay? And then I'm going to have a little set of parentheses, and I'm going to have a big set of parentheses, and I'm going to put SOAP. So same sign, opposite sign, always positive. I'm going to grab my colors. First color, I'm going to keep covering up that -2 so it's not confusing me. Okay, so first color, I'm going to use the 3x. I'm going to do it one time for the little parenthesis, twice for the big parenthesis, until I get halfway through, and then I'm going to switch colors. And I've got the 1, once for the little parenthesis, twice for the big parenthesis. Okay, now technically that -2 should be in each step of what we've done. So what I really should do is put an extra set of parentheses around this right here and stick a -2 in the front. And I really should put a -2 in front of these parentheses right there. So anytime we have a GCF, we really should keep that GCF through every single step of the problem. I'm not as worried about it as long as you know it should end up in the final answer. Okay? All right, so let's bring this down. We have 3x minus 1. 3x times 3x is 9x squared. Plus 3x plus 1. Okay. How do we feel? Better? We do not put the -2 back in there. If you put the -2 back in there, then you're going to have a factor that has a GCF in it. And then if the instructions say to completely factor, you would not have something completely factored. So we leave the -2 out because this is considered to be factored. Okay? Any other questions? Okay. All right, so let me tell you guys what we're going to be doing to practice.